Okay, it's okay that we get started, Tali. Okay, so welcome everybody for the next season of our seminar series. And it's a great pleasure to kick it off with a very esteemed speaker. Tali Sharot is a professor of cognitive neuroscience in the Department of Experimental Psychology and the Max Planck UCL Center for Computational Psychiatry at University College London. She's also on the faculty of the Department of Brain and Cognitive Sciences at MIT. So she really splits her time between London and Boston area. Professor Sharot is a Wellcome Trust Senior Research Fellow and has held fellowships from the British Academy and the Forum of European Philosophy. She's a Deputy Editor for Science Advances and President-elect of the Society for Neuroeconomics. Tali holds a BA in Economics and Psychology from Tel Aviv University and a PhD from New York University, where she worked with Liz Phelps. Sharot's research integrates neuroscience, behavioral economics, and psychology to study how emotion and motivation influence people's beliefs, decisions, and social interactions. She's got awards in recognition of her work, including twice the British Psychological Society Book Award and the Society for Neuroeconomics Early Career Award, among others. She is the author of two excellent books, The Optimism Bias and The Influential Mind. So it's a pleasure to have you here with us, Tali, and the stage is yours.
Okay, thank you so much, Moshe. Okay, so I'm going to talk about how people form beliefs and try to answer the question of what determines the value of our beliefs, which I'm going to answer about 2/3 into the talk. So our beliefs shape who we are. They drive our actions. If I think vaccines are safe, I'm more likely to get vaccinated. They have social implications. They can bring people together, but can also trigger war. And they impact mental health. So negative beliefs can cause stress and anxiety. And the relationship is bidirectional. So our decisions, our social factors, and mental state all alter our beliefs. So that raises the fundamental questions of how do people form beliefs? So if we're able to answer this question, we might be able to use this knowledge to change people's beliefs in ways that can improve their decisions, social relations, and mental health. So the plan for today is to first try to answer this question and then use that answer to try to come up with better insights and develop interventions for improving social relations and interactions online and mental health. But so I'm going to start with the first question, but before I can start with the first question, I really need to answer a separate question, which is why do people form beliefs? That is, what is the function of a belief? So traditional view is that people form beliefs in order to select action that can gain them external rewards, such as power and money and social relations and so on, and reduce the likelihood of harm, such as losing money or getting ill. So for example, if we take the example from before, if I think vaccines are safe, I'm more likely to get vaccinated, that's my action, and therefore more likely to remain healthy, that's my outcome. And I can use these outcomes to update my beliefs. And I can also update my beliefs by observing the outcomes of other people and getting secondhand information. And there are two assumptions inherent in this model. The first is that the more accurate my belief, the better, because accurate beliefs are more likely to lead to better outcomes. But that's not always true. So sometimes I can get rewards that are related to my beliefs and are not associated with whether that belief is true or not true. So for example, if I believe in God, I'm more likely to attend a place of worship, and as a result, more likely to get social support. And that is unrelated to the question of whether my belief is true or not true, accurate or inaccurate. Now, the second assumption is that beliefs are tools to achieve external outcomes. But that also is not quite the whole story. The brain doesn't simply use beliefs as instruments to achieve external reward and avoid external punishment, but rather as a source of internal outcomes that could be rewarding or punishing in their own right. So for example, It's internally rewarding to believe the future would be bright rather than dark. It's internally rewarding to hold belief with certainty. Uncertainty can cause anxiety. It's internally rewarding to believe that you're correct rather than incorrect. And all those beliefs can trigger a reward signal, a neural reward signal that is similar to or perhaps identical to the one that is triggered by external reward. So people are motivated to form beliefs that trigger positive affect rather than negative affect and give a sense of confidence and certainty in the way they think about the world. Now, if this is true, then agents should take actions such as seeking information to achieve beliefs that are internally rewarding, even in cases when they cannot control external rewards at all. So let's look at one such example. So this is a study that was conducted by my former PhD student, Caroline Charpenter, who's now an assistant professor at the University of Maryland. The study is analogous to a real-world situation in which you receive an envelope, perhaps containing a decision on a manuscript, and you need to decide whether you want to open the envelope to learn about the outcome or keep it closed for now. Your decision of whether to open the envelope is not going to change the outcome, right? The manuscript has either been accepted or rejected, but it will change your belief about that outcome at that point in time. Now, our study is not about manuscripts. It's about, we use money. We have blocks of trials in which on every trial you can either win $1 or win nothing. And then we also have blocks of trials in which you can either lose nothing or lose $1. And what we're asking you to do is decide whether you want to open the envelope to learn about your outcome or not. Now, whether you open it or not is not going to change the external outcomes, the money that you get at the end of the study. We will give you everything that is in all these envelopes, whether you open it or not. But to help you make a decision, we tell you about what is likely to be inside the envelope with a pie chart. So this pie chart, for example, says it's 80% likely that you will win $1, and you make your decision. So this task is unusual because the subject cannot control the external outcomes, but they can control their internal outcomes, right? Their beliefs about the external outcomes. And the question is, how do they do that? So first of all, despite the fact that information here is not instrumental, meaning people can't use the information to gain more money or lose more money, most people still want to know. So on the y-axis here, I'm plotting the probability of seeking knowledge. That is the likelihood that people will open the envelope. And you can see that most individuals are above 50%. So most people want to know. But in some cases, they want to know more. And what we find is that when people expect to gain good news, they want to know more. And when they expect to gain bad news, they want to know less. So on the y-axis, again, is the probability of opening the envelope. And on the x-axis in orange is a probability of gaining money. In purple, the probability of losing money. So if you follow the orange line, you can see the more likely I am to gain, the more I want to know. And if you follow the purple line, the more likely I am to lose, the less I want to know. So people want information more when they can use it to build internally positive, rewarding beliefs. You can also see that there's a curvature in the line. And as I'll show you statistics in a second, this curvature is due to the fact that there's a boost in wanting to know when people are most uncertain. So when are they most uncertain? They're most uncertain at the 50% mark, right? That's when really they don't know what's going to be inside the envelope. So we show this by conducting a linear model where we're predicting whether people will decide to open the envelope or not from two factors. One, the likelihood of receiving good news, which is equivalent to the expected value of the lottery. And two, the amount of uncertainty that people are in, which is equivalent to the standard deviation of the potential outcomes. And both of these factors significantly predict people's desire to gain knowledge. But how do we know that these mathematical quantities actually reflect people's subjective feelings, right? How do I know that standard deviation actually reflects my subjective uncertainty and that expected value, in fact, reflects how I think I'm going to feel when I get the information? So we have a few data points to show this. This is one example from my postdoc, Irene Cogliatti-Deza. So if you look on the left graph, what you can see is that the greater the expected value of the lottery, the more people say that they believe they will feel good when they open the envelope. Each line is a different subject. And on the right, the blue graph shows that the higher the standard deviation of the lottery, the more people say that they are under greater uncertainty. So this suggests that EV is indeed a proxy, a good proxy of people's anticipated affect and standard deviation of their uncertainty. And both seem to direct people's tendency to seek information. Okay, so far we see that people take actions to form positive beliefs and to achieve certainty, even when those actions cannot impact external rewards. And there is evidence suggesting that the brain uses the same neural code to motivate those actions as it does for external rewards. So the first clue in this direction came from a series of studies in non-human primates by Borbek-Martin and Higasaka. So what they did is they recorded from dopamine neurons in the monkeys, VTA and SN, the midbrain, while the monkeys were completing a task where they had the opportunity to gain knowledge about the size of an upcoming reward. In this case, it was water. So these neurons in the SN and VTA are known to be reward prediction dopaminergic neurons. So we already know that these neurons usually fire above baseline when the monkey gets a reward that's greater than what it expected. So when the monkey gets more water than what they expected. And we know that these neurons tend to quiet down below baseline when the monkey gets a reward that's smaller than expected, or gets a cue that tells the monkey, you're going to get a reward that's smaller than expected, less water. So these are the normal reward prediction errors that Wolfram Schultz discovered a long time ago, nothing new here. But what Borbek-Martin and Higasaka found was that same exact neurons also fire above baseline when the monkey is told you're about to get knowledge about the upcoming reward. And the same neurons fired below baseline when the monkey was told you're about to remain ignorant, not to know in advance about the size of an upcoming reward. So they named these signals information prediction errors, which are equal to how surprising it is that you're about to receive knowledge. And they concluded that these neurons were treating the opportunity to gain knowledge as a higher order reward, right? So the brain was treating knowledge just like primary rewards, like water and food, or secondary rewards. So we find the same in humans. However, we find that these signals are actually modulated by how good the knowledge is going to be. So the study that I told you about before was in fact an fMRI study. And there's a few things about the study that I didn't tell you before, which I'm going to tell you now because it's going to be important for analyzing the fMRI data. So first of all, when people tell us whether they want to open the envelope or not, they do that by selecting between two blue bars. The more blue in the bar, the more likely we are to open the envelope for you. So if you do want to know what's inside the envelope, simply select the bar with more blue. So in this case, for example, the subject selects the bar with the more blue, and in this case, it's 80% likely that we will open the envelope for them. And before we do that, we tell them what's about to happen. They either see this green knowledge cue, which says in a few seconds we'll open the envelope, or they see a red ignorance cue that says in a few seconds the envelope will remain closed. And what we're interested in is activity at this point in time, when the subject learns whether they're about to get knowledge or not. And what we see is that bold signal at that point in time, in the same exact region as Borbek-Martin saw in the monkeys, the VTA and SN, it tracks the product of two factors: information prediction errors, like even Borbek-Martin saw, which is basically how surprising it is that I'm about to get knowledge, but multiplied by how good this knowledge is going to be, by the expected value of the lottery. So this suggests that the brain uses similar neural architecture and computational principles to process the likelihood of internal and external rewards, right? So the same computations and the same architecture that the brain is known to be using to predict and process actual rewards such as money and water are used here to predict and process the likelihood of gaining knowledge that is positive. Okay, but the brain also has a system in place to differentiate between internal and external rewards. So this again was shown in non-human primates, where neurons in the OFC, specific neurons were shown to be sensitive to internal rewards, and other neurons were shown to be sensitive to external rewards. And this is important because this distinction means that agents can prioritize internal or external rewards based on the environment and psychological needs. So if I'm really thirsty, I'm going to prioritize water, but if I'm comfortable, I may prioritize positive beliefs. And in a little bit, I will expand on the question of when and why we may prioritize one or the other. But before that, I want to answer a more basic question, which is what happens if these two types of rewards are competing? That is, if you can take one action that would lead to internal rewards, but another action that would lead to external rewards. So we put our subjects in this kind of situation in a study that was conducted by my former PhD student, Philip Gesarius. We created a task where participants could bias their beliefs by controlling the evidence that they sampled. So they could choose to form internally rewarding beliefs at the expense of accuracy and at the expense of material rewards. So this was a task. We told subjects that on each trial, they will either visit a phone factory or a TV factory. Phone factories mostly produce phones, but sometimes by mistake produce TVs. TV factories mostly produce TVs, but sometimes by mistake produce phones. What the subject has to do is simply look at all the stimulus moving along the conveyor belt. And whenever they feel they know what factory they're in, they just press the button and tell us whether they think they're in the phone or TV factory. And we incentivize them for accuracy. So they're motivated to be accurate. However, there's also a little trick. And the trick is that we tell the subjects that they have stocks in one of these factories. Let's say this subject here has stocks in the TV factory. Whenever the subject happens to visit the TV factory, they will gain extra points. Whenever the subject happens to visit the other factory, the bad factory, in this case, the phone factory, they will lose points. Now, the subject cannot control which factory they visit, right? MATLAB controls that, and whatever they say is not going to change the bonus points. So really what they should be doing is simply being as accurate as they can. That's the best way for them to gain the most amount of money. But of course, they desire to be in the good factory. And so what we found was that what people did is they required less evidence to reach a desirable conclusion, that is, that they're in the good factory. And when they suspected they might be in the bad factory, they continued to sample information, perhaps in the hope of refuting this negative belief. So here's data showing this. On the y-axis is the amount of evidence that the participants sampled. Because evidence comes in time, it's measured in milliseconds. And on the x-axis is proportion of stimuli that's consistent with the response. In blue are all those trials in which the participants said, I'm in the rewarding factory, in this case TV, and in red, all the ones when they said, I'm in the punishing factory. Now, the takeaway here is simply that the blue line is below the red line, meaning that I need less evidence to reach a desirable conclusion. And we show the same thing by using a psychometric function. So now on the y-axis is a proportion of times if the participants said that they're in a TV factory. As a function on the x-axis is of the proportion of TVs that they've actually seen. In blue are all the subjects for which TV is good, and in red, all those subjects for which TV is bad. And the takeaway here is that the blue line is shifted towards the left, showing us that we need less evidence to reach a desirable conclusion. So for example, if half the stimulus that you see are TV, if TV is the good factory for you, then about 70% of the times you say, I'm in a TV factory. But if TV is a punishing factory for you, for about 45% of the time, you say, I'm in the TV factory. Okay, so what could cause this kind of behavioral pattern? There are at least two possible mechanisms which are not mutually exclusive. One is that you have a prior, before you see any stimulus at all, you already have a prior to believe I'm probably in the good factory, right? And so you need less evidence to reach that conclusion. Another option, which is not mutually exclusive, is that you put more weight on each positive piece of evidence than each negative piece of evidence. Again, that would then lead to the same pattern of results. So to tease these two mechanisms apart, we fitted the data to a drift diffusion model. So a drift diffusion model allows us to estimate the factors that underlies the decision process. So the basic idea is that I can reach one of two belief states, in this case that I'm in a desirable, undesirable factory. I start somewhere in the middle, we call that a starting point. And then each time I have a piece of evidence, I move either up or down based on whether the evidence is pointing up or whether it's pointing down. And then at some point, I'm going to reach the threshold. And when I do that, that's when I tell you what I think. So it could be that I'm starting in the middle, so I have no bias. Or maybe I'm starting closer to one threshold. Let's say I have a bias towards desirable beliefs. If indeed this is the case, you can see it take me less time to reach the desirable threshold. And indeed, we do see a bias in the prior, but it's very small. It's significant, but very small and not always replicable. The other option is that every time I see a desirable piece of evidence, it pushes me up more than an undesirable piece of evidence pushes me down, right? And that ratio is called the drift rate. And indeed, we see that there is quite a significant and replicable bias in the drift rate towards desirable stimulus. So it seems that people do put more weight on every desirable piece of evidence than undesirable piece of evidence. Okay, so people seem to actively form internally rewarding beliefs, which are sometimes inaccurate at the expense of external reward. And the big question is why? How could this be adaptive? So one popular speculation is that having internally rewarding beliefs is adaptive, even if these rewarding beliefs are biased or maybe even called positive illusions. And many scientists have held this point of view. For example, Daniel Dennett has called these design features. Eric Bandura has pointed to how they enhance self-efficacy. Shelley Taylor have provided evidence for a correlation between positive beliefs and physical and mental health, for which Martin Saligran have provided data for causation. And the idea is that if I have these kind of positive beliefs, it enhances my motivation, enhances my exploration. And all of these scientists as well point to the fact that it can have a cost, right? If I have these positive beliefs that are inaccurate, I might not take the precautionary action that I need, right? I might underestimate my risk, and that can lead to negative consequences, but they say probably on balance, the advantage of having these beliefs outweigh the disadvantage. Now, a more nuanced view is that whether these kind of biased beliefs are adaptive depends on the environment that we're in. So in a relatively safe environment like you and I are in today, perhaps these biases are adaptive because of enhancing motivation, exploration, and so on. However, if I put you in a threatening environment, rife with threat, right, there's lions around, then perhaps they are disadvantaged. You really want the most accurate beliefs that you can. So they say, well, whether it's adaptive or not depends on the environment. So our view builds on this, but is somewhat different. So we suggest that what is adaptive is not the belief itself, but what's adaptive is that the brain can prioritize either internal or external rewards in response to the environment that we are in an adaptive manner, and it can do that using flexible learning mechanisms. Let me explain exactly what I mean. So if you're in a relatively safe environment and all your basic needs are met, then you might prioritize internal outcomes, such as creating these positive beliefs, which could on average also be beneficial in the long run for external outcomes. If, however, we're in a very dangerous environment, we may prioritize forming unbiased beliefs, so that internal outcomes may experience a hit, but this is for external outcomes, for the purpose of reducing the likelihood of negative external outcomes and enhancing the likelihood of positive external outcomes. And the way that we can prioritize one or the other is by adjusting how we seek information and how we then use that information to update our beliefs. Okay, so to test this, what we're going to do is we're going to put subjects in a threatening environment, and we're going to see whether the way that they sample information and use it to alter their beliefs alters in a way that's consistent with this theory. So to do that, we conducted a study conducted by my PhD student, Laura Globig. We had two groups of participants. One group was the threat manipulation group. We told them that they're going to have to give a talk about a surprise topic that we gave them. They're going to be rated and judged, and then we're going to tape them and put it on YouTube. We also had a control group. The control group was told that they're going to have to write an essay about a topic that we would give them, but no one's even going to read it. To make sure that the manipulation worked, we asked them to rate their stress levels before and after the manipulation. And indeed, the manipulation worked perfectly. And then we gave them the factory task that I just told you about before. So what did we find? We found that in the control group on the left, the same results as before. People required less evidence to reach a desirable than an undesirable conclusion. But in the threat group, this bias went away. And now there's no difference in how they accumulate information to reach either a desirable or undesirable belief. And if you look at the drift rates, you see the same exact thing. So in the control group, we again replicate the drift rate bias towards desirable information, while in the threat group, there is no significant bias. There's a little bit towards negative, but unfortunately, it wasn't significant here. Okay, so what this suggests is that we prioritize short-term internal or external rewards based on the environment that we are in, such that in safe environments, we accumulate information that could lead to internal rewards at the cost of external rewards, but less so in threatening environments. I'm just seeing there's something in the chat. What if the subject is post-traumatic, whereas he's perceived neutral environment as life-threatening situation? Did you study that? Okay, so the question is what happens with people with mental health problems such as PTSD? We didn't study PTSD in particular, but we have studies in people with depression. It's a slightly different paradigm, but the idea is very, very similar. And what we find is people with depression who are not hospitalized and not under medication, they show the same thing. So they tend to now have no bias at all in the way that they update their belief in response to positive and negative information. This, by the way, was a question from Moran. And then people with severe depression that are hospitalized, we actually see a flip. So now they are starting to update their beliefs more in response to negative than positive information. They're putting more weight on negative information than positive information. And that makes sense because people with depression and other mental health problems usually are under higher stress, right? And we show this in depression, but other people have shown this in different mental health problems, such as schizophrenia, and I think there were a couple others as well. And also, I'm going to talk about mental health in a little bit. Well, towards the end, there'll be a whole section about mental health too. Right. Okay. Thanks for that. Okay. So I'm going to summarize this first part. What we show is that participants are motivated to seek and use information to form internally rewarding beliefs that increase positive affect and certainty, even at the expense of external rewards. The brain uses similar neural architecture and computation to code for such opportunity as it does for external rewards. And participants can prioritize internal or external rewards in a seemingly adaptive manner by altering the way they accumulate and use information to form beliefs. Okay, so now as promised, I'm going to try to answer this question. So what is the value of a belief? Okay, so far I've focused on the potential external and internal outcomes of a belief. But there's another distinction when we think about the outcomes of beliefs, and that is whether these outcomes are dependent on the accuracy of the belief or independent on the accuracy of the belief. So I'm going to go through all of these quadrants to kind of explain what I mean. Let's look at the left top quadrant. Some outcomes of belief are external and they are independent from the belief accuracy. For example, let's say that I live in a state where I'm more likely to get a job if I believe in God. The outcome of the belief is external. It is getting the job. And it is independent on whether the belief in God is accurate or inaccurate. So that's an example of the outcome of belief, which is external and independent of accuracy. A lot of outcomes of beliefs are external and they are dependent on accuracy. For example, I think the market is going to go up, so I'm more likely to put my money in the market, and whether I gain or lose, which is the outcome of the belief, depends on whether my belief was accurate or not. Some outcomes of beliefs are internal and they're independent of belief accuracy. For example, I apply for a job and I think I'm going to get it. That belief causes me to feel good, right? It's internal. And that feeling is unrelated if it turns out that at the end, my belief was correct or incorrect, whether I get the job or not. Other outcomes are internal and they are dependent on my belief. So I think I'm applying for a job, I think I'm going to get it, and then I don't get it. I feel disappointed. So that disappointment is an internal outcome, and it is dependent on whether my initial belief was accurate or inaccurate. So our suggestion is that the value of a belief is a summation of the potential rewards and punishments of holding that belief. And in different environments, these outcomes are different. So if I move from a secular environment to a religious environment, from a safe environment to a threatening environment, from a conservative environment to a democratic environment, in all of these environments, the outcomes of belief can be different. And so if I want to hold the optimal belief, I should change my beliefs as I move from one environment to the other. Okay, so for the rest of the talk, what I'm going to do is I'm going to take this kind of framework to try to better understand some real world problems. And the first one is misinformation online. So we all know that misinformation online is a problem, and especially in social media platforms. And in a recent op-ed, I highlighted that the spread of misinformation is due to the reward structure of social media platform, where the outcomes of sharing your belief and perhaps even holding it are external, right? Retweets, likes, and so on. These are the rewards, but they're independent from the accuracy of the belief, right? So many times there's many studies that show that content that is inaccurate, that is false, tends to be retweeted at least the same or sometimes more than accurate beliefs. And so if we want to tackle the problem of misinformation, what we need to do is we need to offer people outcomes, rewards, and punishments that are dependent on accuracy. Now, any kind of reward and punishment that are dependent on accuracy will work. The suggestion that I made was to add these buttons, which are trust and distrust buttons. And the reason I suggest that is simply because trust, by definition, is a belief in the reliability and accuracy of something. And so the idea is that, first of all, people will use trust and distrust buttons to discern between true and false posts, more so than the available options now, than likes, hearts, and so on. And if this is true, then now users will find themselves in this new environment where they can get these carrot trusts by sharing more true information, and then they can avoid the distrust sticks by not sharing false information. So that means that misinformation online should be reduced. And if all this is true, that they may actually lead to an increase in the accuracy of people's beliefs. So to test these hypotheses, my PhD Laura Globig conducted a study that had a few parts. In the first part, we showed participants 100 different posts, and they could react to these posts. They could press like, dislike, trust, distrust, or skip, and they can also press more than one, as many as they like in regular social media platforms. And the idea was to see whether they will use the trust and distrust more to discern true from false information. So half of these posts were true and half were false. Okay, so the y-axis, we're plotting discernment, which is the endorsement of true minus the endorsement of false post, and the disendorsement of false minus true post. So first of all, when people press dislike, yes, they did discern from false information and then true information, meaning they pressed dislike more for false and true. They also pressed like more for true than false, so they discerned as well. But they used trust and distrust much more to discern true than false information. And this was true for Democrats and for Republicans. This was tested on US participants. Okay, so this suggests that the first hypothesis is supported. People do use trust and distrust more to discern true and false information. So now we're going to put people in this new environment where they can get trust and distrust, which apparently is associated with better discernment. So we have a fresh group of participants. They see the same 100 posts, and all they need to do is decide whether to repost or to skip. The idea here is that there's different groups of participants, and each group of participants gets a different type of feedback. So they decide whether to repost or not, and then they get feedback. The feedback is real feedback from the other participants, okay? But the type of feedback that people can get can be different. One group of participants only gets trust feedback. They see how many people trusted their post. So if they get 1 trust or 5 trust, it's okay. But then when they get 20 trust or 100 trust, that's even better. So they would learn pretty fast that, you know, to get a lot of trust, they should probably post more accurate information. Some people only get distrust, but of course the magnitude matters, right? Sometimes they get 100 distrust. That's really bad. Another time they would get only 5 distrust. Some people get only like, some only dislike, some get trust and distrust together, some get like and dislike together, and some get no feedback at all. That's our baseline condition. Now, notice that the feedback here will not alter their decision on the same post, right? First, they make a decision about the post, then they get the feedback about the post. So the feedback about that post cannot change your decision about that specific post, but it could change your decisions about posts that come later on. The idea is that you probably learn, oh, if I want to get these trust and less distrust, I should post more true than false information. So that's kind of the hypothesis. So now on the y-axis, discernment is a proportion of reposting true content minus a proportion of reposting false content. And we can see that indeed participants who were in the trust-distrust environment were posting more true than false than people who were getting no feedback at all baseline, or people who were getting like and dislike. And that was also true for people who only got trust, only distrust, only like, and only dislike. It was also true for different types of content. So we had content about science and health, environment, politics, society. In all of these cases, being in the trust-distrust environment increased the discernment of reposting. Okay, so what are we altering here? By putting people in this new environment where outcomes are more associated with accuracy, what are we changing in the decision-making process? Well, let's think about it. You see this post and you have to decide whether to repost or skip. What do? Well, you look at the image, you read the text, right? You also may retrieve some information that you had from before. What do you know about this content? What do you think other people will say? So if we think about it like that, then it becomes an evidence accumulation problem where you can reach one of two decisions. You can either reach a good response, which means I'm going to repost true content or skip false content, or you can reach the bad response, which is I'm going to post false content or to skip true content. So you start somewhere in the middle, and then you're starting to accumulate evidence from outside you, from inside you. And so if I put you in this environment where rewards are more associated with accuracy, how does this change the decision-making accumulation, evidence accumulation process? Well, two things can happen, which are not mutually exclusive. One is that you become more conservative, right? You have your threshold larger, so you need more evidence to reach one or two of the decisions. Now, assuming that the signal is greater than the noise, if this happens, that means that you're more likely to reach the good response. The other option is that you put more weight on each piece of evidence that drives you towards a good response versus weight that drives you towards a bad response. So that is known as a drift rate. And we found that the latter was true. So by fitting people's data, the reaction times, and their decisions into a drift diffusion model, we see that people in the trust-distrust environment had a larger drift rate than in the other environments, meaning there's greater weight on evidence that pushes you towards the more accurate responses. Okay, so we are able to increase discernment. And the last question is, does it really also change people's beliefs? So to test that, we simply showed people all the content again at the end and asked them to rate each one on how accurate or inaccurate they thought it was. On the y-axis is the amount of errors that they make. So smaller numbers are better, they're more accurate. And you can see that indeed people in the trust-distrust environment were more accurate. Okay, so I think I have like about 4 more minutes or so. Is that 5 or yeah? Okay, so this is basically just repeating what I said, and I'm just going to jump to our last point within the last 5 minutes, which is moving into mental health and talking a little bit about what is a relationship between this framework and mental health. So many mental health problems can be the consequence of external circumstances, such as poverty, losing a loved one. But many times, these mental health problems are characterized by negative beliefs that are dissociated from external outcomes, but nonetheless trigger kind of internal punishment, anxiety, low mood, and so on. And these beliefs are formed partially by an agent that is actively gathering information, which can trigger fear, anxiety, and uncertainty. And nowadays, a lot of this activity actually happens online, right? People use online information to gather evidence and form beliefs. And the idea is that perhaps mental health problems are related to suboptimal patterns of information gathering. Now, if this is true, if there's a relationship between information seeking online and mental health, this could be very useful information because people engage in online information gathering every day, all day, right? So there's a constant stream of data that we could potentially use to detect mental health problems early and intervene. So the idea is, for example, that if someone tends to seek information that tends to be negative, because perhaps that reflects their internal thoughts, then that negative information can then make the symptoms worse. And that will then lead them to seek more negative information and so on. So to test this, my PhD student, Chris Kelly, conducted a study where he asked participants to browse the web for 5 days, each day for about half an hour, and then simply send us the history of their browsing. So they just go into their history browsing, they cut and paste it and send it to Chris. So now Chris has all the web pages that the participants looked at. He can go into those web pages. He takes all the text out of those web pages, cleans it, and then feeds it into algorithms that score the text on positive valence, negative valence, and basic emotions, such as joy, fear, anger, and so on. And what we're going to do then is see whether there's a relationship between the type of information that people consume from self-guided searches and their mental health, which we know from questionnaires that we give our participants. We give them a whole range of questionnaires to test their mental health symptoms. They also indicate their mood before and after their browsing sessions. Okay, so first of all, what algorithms do we use? There's quite a lot of algorithms already online that you could use to score positive, negative valence and basic emotions. Mostly, they are one of 2 categories. Either they're bag of words algorithms, which basically are algorithms in which there are a few thousand words that have been already scored by many, many participants on how positive and negative they are. You take your text and it simply matches to see, well, do the words in the text, are they scored as positive and negative? And they give you a score. The other common algorithms are machine learning algorithms. And what we find is that it doesn't really matter which one you use. The correlation between them is almost 0.9. And so we use a bag of words approach because it is less cognitively, less computationally demanding. And we also make sure that those scores that we get from the bag of words algorithms are actually reflective of how subjects score the web pages. So we have subjects score how positive or negative web pages are. This is a different group of subjects, and we can see there's a nice correlation. Okay, so we can use these scores. So now we're going to take these scores for each individual. There's a score of how positive or negative information is of the information that they consume from self-guided searches. And what we found was that these scores, specifically the negative score, correlated with the severity of psychopathology symptoms. We have two studies, the first study and its replication. And basically you see that the higher the negative scores, the more psychopathology symptoms participants express, and that it seemed to be a general fingerprint of bad mental health. It wasn't specific to one condition. Okay, so the obvious question is, what is causing what? Is it that I have problems with mental health and that is causing me to go out and seek more negative information? Or is it that I happen to have a tendency to seek negative information, and as a result, that causes these mental health symptoms? So we did two things to answer this question. The first thing we did is we had participants rate their mood before browsing, and then we related that to what they then browse. And we see that indeed pre-browsing mood was related to how negative the information was that they browse. So people with worse mood browse more negative information. And then we looked at whether the negative or negative information that they browsed was related to their mood after browsing, controlling for their mood before. And indeed, if you go out and browse more negative information, you end up with worse mood, controlling for your mood before. So this is the first piece of evidence that suggests that the relationship is bidirectional. However, this is not causation still, not causal evidence. So we did another study where we manipulated the type of information that people consume. For one group, we gave them negative web pages to read, and the other one, we gave them neutral web pages to read. And then we looked at their mood after browsing. And indeed, we found, maybe unsurprisingly, that people who browse more negative information that we gave them ended up with worse mood after browsing relative to before, and also just worse mood relative to the control group. So now we created two groups of participants. One has a negative mood and one has a neutral mood. And we looked at, okay, now you can go online and browse whatever you want. And we found that those with negative mood, which we induced, ended up browsing more negative information. So this suggests that there's really a causal bidirectional relationship between what people browse, the valence of what they browse, and their mood. And if this is the case, we thought, well, it may be helpful if we tell people in advance what is the valence of the content that they're about to browse before they browse, right? A little bit like before you decide what to eat, you look at the nutritional value of the food, sometimes if you want to, in order to make decisions. So you can see how many calories, sugar, and protein is in the food before you consume it. The idea is, can we do the same thing for information? Before you consume information, we will give you nutritional value so that you can make better decisions. So what kind of nutritional cues are we going to give you for information? So we have a whole other research, it's not related, but associated research program where we kind of look into this, and I won't go into much detail, but basically what we find is that when people think about what information they want to consume, they care about three things. Will the information help me select better action to help me gain reward and avoid harm? So is it actionable? What is the valence of the information? Can I use it to regulate my affect? So is it positive or negative? And will it increase my understanding of the world, right? Will it have an effect on my cognition? So what we did then is we developed these algorithms that you could use as a plugin or you can use in an app. Every time you Google something, it shows you the Google results. But next to the Google results, it also gives you scores on these three elements. So you already know how we calculate the emotion, the valence of text. So it shows you like this one is quite negative, this one is less negative, and so on. We also have algorithms. These are machine learning algorithms that score how actionable the text is and how likely it is on average to increase knowledge. So now for each one of these things, you have these different cues, and that can help you make better decisions about what information to consume. So for example, if you want to make a banana cake, you might focus on actionability. But if you want to learn about World War II, you might focus on knowledge, right? Or if you're trying to change your affective state, you might focus on the emotional cue. And so far, we've tested only the emotional cue to see whether people in fact use it. So we had two groups of participants. One, we showed them Google searches with the regular Google results. And the other group, we also showed them these cues that tell them on each one of the results, is it likely to make you feel better, worse, or doesn't have an effect on your emotions. And what found was that indeed people who saw these labels were more likely to click on the web pages that suggested that it will have a positive effect on their mood, and less likely to click on those that suggest that they're going to have a negative effect on their mood. Suggesting that if you give people advanced information, they do use it to alter the type of information they consume. Okay, so that's it. To summarize, the suggestion is that the value of a belief is a summation of the outcomes of holding it. Some are external, some are internal, some are independent on accuracy, and some are dependent on accuracy. In different environments, the outcomes will be different. And so the value of a belief is different. So you may change your beliefs when you move from one environment to the other. And if we can influence which beliefs we hold by the way that we search for and use information. And if we want to alter other people's beliefs, we need to alter the incentive structure of holding it. And we think this very much may help for understanding human beliefs and creating healthy information ecosystems. And just finish by thanking the lab members and our funding sources. Thank you.
Thank you very much, Tali. Really enjoyed it. So if you have a question, you can unmute yourself and go ahead. Otherwise, I have a couple of questions also. Okay, so I'll start while people are gearing up, Tali, if you don't mind. So the first one is somewhat technical, but is there a way, if you're comparing whether individuals gravitate towards more the external or the internal belief or / reward, do you think there's a way to actually equate their value, their magnitude? So can you really compare, is there an axis along which you can really grade the magnitude of external versus internal?
Well, I think what you could do, I mean, the one thing you could do is create a task where people make choices, right? A little bit like our competition task. So that's normally how you try to find the kind of the equation point. The only thing is that I think perhaps and I think that may work. People are not necessarily conscious of what they're doing. So that could be, a problem with this approach. But I think that's probably the best way. For a while we were thinking about a way to try to measure, right? Really measure it. And it was like very, very, very difficult to think about. How do you do you ask people? What do you do? Mm-hmm. Yeah, it sounds like a very difficult thing to do. So I think that's the best that I could think of.
Okay. The second thing is curiosity. So I'm trying to think about our drive to accumulate more information in order to form more accurate beliefs. And curiosity is, I'm sure you would agree, can be seen as a trait, but also as some sort of a state, right? Do you notice that people at different states tend to try to make their beliefs more accurate than other states? And what are these states? Can you characterize them?
So I actually don't think that people accumulate information with a desire to reach accurate beliefs ever. I think that what they're trying to do is either increase their external outcomes, right? More external rewards and less negative rewards, and or the internal outcomes. Now, because in world, often there is a correlation between gaining the external outcomes and accuracy, then we often talk about people trying to create more accurate beliefs, but I actually don't think that is the motivation. I think the motivation is simply to optimize my situation. And sometimes that optimization is related to gaining more accurate beliefs, and sometimes it's not. I'm not sure you agree with me, but at least you understand, if you understand my point.
It's surprising, but it might be my still evolving way of trying to understand what a belief is. I mean, if I try to form a belief about whether organic food is really healthier, then I definitely try to accumulate more information in order to decide.
Right, but your motivation is not to be accurate. Your motivation is to remain healthy, right? And in this case, it is likely that if you're accurate, you will then, right, gain information and make better choices and become more healthy. But not necessarily. Like, you can also imagine a situation where, but again, the important thing is that it's not your motivation. I don't think your motivation is to gain accurate beliefs. Your motivation is to remain healthy, right? To have these external outcomes, which is health, right? But sometimes these kind of beliefs can be inaccurate and make you more healthy. Like, for example, if I underestimate my likelihood of, being ill or something, it can actually have positive impact on my mental health, and then actually counterintuitively make me more healthy, right? So that's my point. Like, we talk about it as if the motivation is to have accurate beliefs, but really my motivation is to survive, right? And that's kind of the way I think about it. But then I could still answer your question, which was something like, in which state, right? So I think, and because I don't think the motivation is to have accurate beliefs, when I answer that question, I answer it as, in certain states, my external outcomes matter more. And in certain states, my internal outcomes matter more. And the states that external matters more is these kind of threatening and dangerous environments, because the risk is so great. But it could be things like poverty, like those kind of things where there's external needs and there's threats. In those cases, the external outcomes will matter more. Doesn't mean that accuracy matters more.
Tali.
Yeah.
Hi. Yeah. Thank you for the talk. I mean, super important as well nowadays, more than ever, I suppose. And sort of going along with your comments now about the motivation. I mean, I wanted sort of to push it a little bit and ask that in some sense, I think people also vary in their commitment to their beliefs. I wonder where does that play into your model? I mean, it of course can play into the affect, of course, the effect on affect that the beliefs have, because people have, their identities may be defined by the beliefs that they hold.
Yeah. So I think
or
there's
group identity. So for going, no, go ahead.
Yeah, sorry, there was a delay. That's why I think you froze. I agree. So I think there's probably two things where this comes to play. One is the one that you mentioned, which is kind of these internal rewards. I mean, I could call them feelings. I'm not sure if that's the most accurate, but if I'm more committed to my belief, I will feel worse by changing it, right? That's internal. But there's two other things that matter. One is, often if I'm very committed to the belief and I'm part of the group, changing the belief is going to have these external consequences, right? More so if I'm highly committed to it. So we can think about regular examples like political affiliation is obvious. But if you think even about extreme examples, like people who believe in flat Earth, I don't know if there's a great documentary, I think it was on Netflix, about people who believe in flat Earth. And it's a community, right? This belief in the flat Earth gives them social community. I mean, it gives them a lot in their life. So now if I don't believe in the flat Earth, then I'm losing all of this community. So there's an external consequences to changing my belief, right? So I think as you're more committed, the external outcomes are different, and also the internal. And then the last thing I did not mention, and I don't talk about a lot, is there is a cost to just changing a belief, just a mechanical cost, right? And as you have a stronger belief, the cost will be greater. You can just think it about like kind of resource cost as well. So that comes into play as well. Yeah, thanks.
Great. Any more questions? Okay, Tali, thank you very much again. I know you had to wake up early for this, but we really gained from that. So I really appreciate it. Thank you very much again.
Okay, thank you so much. Bye-bye.
Bye.